Do you guys have any questions regarding your apps?
Probably. I've been trying to get a list.
Okay.
I got a list to go into a database.
Okay.
A list of objects.
Mm-hmm.
And then I'm trying to use an array adapter to pull it back out, and I haven't been able to get that to work.
Okay.
So either I might just have to switch gears and just simplify it and just do the key value database and put a counter or something instead of trying to get it to work the way I want it to work.
Okay, so are you using Firebase?
No, I'm using SQLite.
Okay. And how are you storing a list of objects?
I have a custom class,
Okay.
and then I made a custom table in the database. And I was actually able to open the database, and it's storing them correctly. So it's just the pulling them back out that I'm having a problem with.
I see. So can you verify, that it is in the database?
Yeah, I found a SQLite viewer.
Okay, so it's a
I was able to
client.
open the file.
Okay, gotcha. We can take a look, after the lecture portion. So
Okay.
it's kind of, we're kind of flexible. We can make this portion longer or shorter.
I just threw the SQLite out of mine. It's taking me down a rat hole.
It does, right?
SQLite?
I'm going with a flat file now, and I'm just remodeling it. I guess if I was bigger, it would be more necessary.
I see. Is it a query part, or is just all the nuances?
It's a silent crash. I have no
Okay.
idea. It's just poof, gone.
I see.
I don't know where it went.
Okay, so today's main topic really has to do with mobile, other mobile programming languages. So I pulled out some really kind of older article from 2015, one that was a little bit newer, 2016, and one that is relatively new, which is May 8th, which is like 2 days ago, in 2017. So you might notice something that is common between all of these articles. And then Android on everything or not, that's just a really kind of historical look at Android itself, and also where mobile programming is going in the near future. Okay, because if you plan to kind of do more of these type of development, you might want to kind of keep in mind what kind of changes is coming. There are a few kind of new things that are coming, and I think there are a few things that I think will be coming, but it's not really visible yet. It's not on the horizon, but I think it's going to happen. Okay, so we'll start with this kind of older article from 2015, if I remember correctly. It's from BuildFire. They're trying to sell their own product. It's a mobile app builder for both iOS and Android. So they're trying to unify software development between all the mobile platforms, or the two main mobile platforms. I have no idea of the market share of Windows Phone, in the market. I don't think they're significant.
I don't know hardly any people that have them. There are like 2 people that have them.
I know some people having them, but that's only because they're inexpensive.
Are they? I thought they were comparable. I didn't think they were really cheaper.
Well, they had to lower the price, just to stay competitive. So this is relatively new.
99.6, wow.
Yeah, so Windows can only be the other 0.4%, right? So if you look at how much effort.
No, it's BlackBerry that's the rounding error. It isn't even Windows.
It's the old BlackBerry. Well, BlackBerries are interesting because they have hardened versions of those, which
They've been around for a
Obama
while.
used. Yeah, Obama only used a BlackBerry because it's already hardened. So it's not nearly as hackable as some of the iOS or Android devices. So there we go. We have the answer to why BlackBerry's market share is around the error. That is funny. Okay, but if you look at the 0.4%, and you look at how much effort Microsoft has to put into maintaining a different operating system, because it is different. It's not the same as your desktop Windows. it's not worth it. I think Microsoft is not gonna, is not gonna continue with their mobile platform.
What's the split between Android and iOS?
Well, let's read
Android's
it.
ahead, right?
Android is ahead. I have read some bar charts, but this is not a bar chart, but it's close enough. So when you look at the percentage, it shows you the change over time too. You can see the market share of Android is creeping up from 15 to 16. Not a whole lot, okay? We're not looking at a very dramatic change here, but it did go from 80, it went up by 1%, basically.
Yeah, 80,
That's 1% going up. iOS, gained by another 0.2%. Windows lost. That's where those percentages are coming from. Is Windows is going down, BlackBerry is now becoming 0.0, and there are quote-unquote others. I think Ubuntu is trying to make its own mobile, interface on phones. I don't think that's going to fly, but that's just me. Because at this point, we have such strong contenders from two really large companies. Any new entry is going to there'll be a lot of difficulties for new entries. The main thing is not even the operating system. I mean, you can have the best, operating system and not be able to gain any market share because there are no apps. Okay, because in order for anything to get traction these days, it has nothing to do with how solid the operating system is. It has nothing to do with how little hardware it consumes, how long the battery life is and stuff like that. It has to do with apps. If you do not support most of the apps that are now either in Google Play market or the iOS market, it's not going to sell. You can have the most rock solid platform, it's not going to sell. It's not the same day when we have those Nokia phones that is monolithic, it has a keypad, and you only use it to call somebody, right? Those days are over. Okay? We don't use phones the same way that we used phones in the past. So this is rather interesting because you can see that Android is continuing to creep up in terms of market share. iOS is doing it as well at the expense of Windows. Because Windows is the only one that's going down, along with BlackBerry, which basically disappeared.
And they lost 700,000 units this month.
Yeah. Yep. But so it's now 2017, first quarter, basically we're done with the first quarter of 2017. You can probably expect the numbers to change very slightly, but in the same direction. I think between iOS and Android, it will be very...
When did they switch? Because iOS had the platform originally. So they must have switched in what year?
There was a bar chart that I saw earlier. So let's look up a bar chart, mobile app share, market share, and look up images. Because I saw one earlier today. Okay, these are not the ones that I want to see. Those are ads. Okay, maybe not. That mobile app market share. There we go. There we go. That's better. And you were looking for when they switch over, right?
Yeah. Got a year.
Well, these are just apps and downloads, but it does give you an idea. I saw one earlier today, and it was a pretty good chart. Okay, we can try to find one. But I think they caught up, like 2 years ago, or longer.
Yeah, and it's growing rapidly. Android's the platform to build for. Don't waste your time on iOS.
I think it's at least 2 years ago because I remember I was in Hong Kong at the time, and I was talking to people who were interested in app development. So in Hong Kong, they have a lot of contractors. They do not originate the idea; they only implement, the idea of other people. And I was talking to those people, and that was the year when Android basically took over iOS, and most of the developers said, well, it's not even worth their time to kind of continue to train in iOS programming, or they're at least considering Android to be equal at that time. The
80%.
yeah, the market in China is different too. You have to remember the market in China is a lot more iOS leaned. People tend to use more iOS devices compared to Android devices because in mainland China, your device is kind of a symbol of status. Okay, it's not it's not just for pragmatic purposes. You pull out an iOS device, you pull out the iPhone, people look like, oh, you got the good stuff. You pull out an
You
Android.
paid 4 times as much as I did.
Yep.
You could afford it.
It's exactly it's a symbol of status. Okay, so it's the comparison of driving a Porsche convertible versus a Geo Metro convertible, but you're stuck in traffic anyway.
Yeah.
The Geo Metro with 3 cylinders would make pretty good use of that tank of gas. I saw somebody selling one of those on not Winding Way. I cannot remember the name of the street. It's the one that connects to Winding Way. Just cannot remember the name of the street, but somebody was selling 2 Geo Metro convertibles. I think one was $2,000, which is actually pretty expensive for that kind of car. But if it's well maintained and it's a 3-cylinder version, I want it. I don't want a 4-cylinder version. I want a 3-cylinder version. 3-cylinder version. Those things are cute. So anyway, yep, 80% of market share is huge, which basically means that nobody can at this point really challenge Android or iOS.
They're shipping 1 billion units a year.
Yeah.
1 billion to something, 1 billion more.
You seen anything about the Google's OS that they're developing?
Fuchsia.
I think thinking
Mhm.
Magenta, Fuchsia.
Yeah, I was just about to talk about that. It's actually in my notes and I typed something about it. Yeah, so Google Fuchsia is something that is kind of we don't know the intention. We know it exists, but we don't know the exact intention of Fuchsia. So you can go through different types of sources. Wikipedia probably is the best one because people tend to keep it updated. It's a capacity-based real-time operating system, RTOS for real-time operating system, which makes it different from Android because Android is based on Linux, and Linux is for the most part a general-purpose operating system. Now people have tweaked it to turn it into an RTOS, but by design it is not an RTOS. It's not a real-time operating system.
Can't guarantee it's scheduled.
No, exactly. The kernel itself has no concept of real-time scheduling. It has scheduling, but there's no guarantee of real-time scheduling. Has no priority queue. There's no prioritization of threads and go like these are high priority. If there are
What's the priority? It's actually the priority inversion problem that they have to solve. You have a high
It's waiting on
priority,
something
you have
that's
a high
lower
Now
priority.
you're waiting on a lower priority, so blah blah blah. And then the whole thing has to unchain itself.
Well, but that is that's an architecture problem. That's how the components are interlinked. So the problem is not in the kernel itself so much as it is also dependent on the drivers and the other components. So it's basically its own operating system. It's developed by Google. It was first discovered as a mysterious code post on GitHub in August 2016. So we are talking about less than 1 year ago when it was first discovered. Now we don't know exactly how much time Google has already spent on it. The other ones, the other so-called Google developed operating systems are not really operating systems. Chrome OS and Android are both Linux-based, which means Linux has done most of the heavy lifting. When it comes to talking to the hardware, managing the memory, managing how you allocate processing resources to the threads, how to create processes, how the file system operates and stuff like that. All that heavy lifting is already done by Linux. So Chrome OS and Android really are just stacks on top of the operating system. It's mostly the GUI part, the part that interacts with the end user. Much like what you're seeing right here. Okay, I'm running Linux as the baseline operating system, But X window and with XFCE4 on top of that is providing the actual quote-unquote user interface, the graphical user interface. So I would say Chrome OS and Android are basically quote-unquote lightweight GUIs. So Fuchsia is based on the new microkernel. This term microkernel is interesting because it is it's not a new term. It has been around for a long time. There are only a few operating systems that actually use microkernels, and Linux is not one of those. Linux uses a fairly kind of monolithic, big, clunky kernel, which is not very elegant in terms of design. One of the microkernel, commercially available microkernel is called QNX. Now, I don't know who bought them, okay, because I know that QNX got bought by somebody, but it's a real-time operating system that was used in nuclear plants and some other really crucial applications.
Bought by BlackBerry.
Sorry?
Bought by BlackBerry.
BlackBerry.
Research in motion.
And now BlackBerry is no longer. But QNX, when it was around, it is actually a very interesting platform. So if you look into QNX as an operating system, and I would go to Wikipedia instead of their own website because they want to kind of push their product. But this is where you can find more about QNX. I encountered QNX because I had a background in embedded system design and development, and in those trade shows, QNX does not usually have a very big booth, but at the same time, when you look at how the kernel is designed and stuff like that, it's really cool. It's a very small, tiny kernel. It takes up a very little code space, and everything else are modules that are pluggable, to the microkernel. You can update just about everything on the fly without having to shut down the entire operating system. Okay, it's not like Windows. Every time you have an update, what do you have to do? Reboot 26 times. Well, not quite, but at least once or twice. At least once or twice, and then when you reboot, what happens? You see all those updates, right? And it takes a long time to shut down, and it takes a long time to restart to finish up the updates. Not QNX, okay? You can do most of the updates without actually having to shut down or reboot the computer. That's the difference between a microkernel-based operating system as opposed to a kind of regular monolithic operating system. And Linux is not microkernel. Linux is actually pretty clunky. The base code of Linux is not very modular. Okay, so it's kind of cool. They name everything after really kind of bright, high saturation colors. Fuchsia is one, and then they have magenta being the other one. So it's an operating system intended for embedded systems, which is actually an interesting indication, because they're not going to do this just for mobile apps. So Fuchsia is not really designed for mobile applications or mobile platforms, even though people have found it on tablets. Okay, but I think that's just one of the applications that Google has found. It's kind of like, well, we can do this on mobile applications. I think Fuchsia has a much more ambitious plan. Google has a much more ambitious plan for Fuchsia. I think it will find its way into self-driving cars, for one thing. Okay, now if you think about self-driving cars and the components inside any type of vehicle, they are real-time based.
They better be.
The collision sensor, and when to fire and how to fire the airbag. You cannot just say I'll get to it later. I'll finish all the other things in the what is that name? The event queue. Okay. Oh, somebody want to change the window configuration. I'll finish that before deploying the airbag. No, you're not going to do that. You have to. Certain things are real-time based. You have a time window when you have to respond, and then RTOS is intended to get those things done. Okay. Engine control is one of those. Anti-lock brakes would be one of those too. So I think Fuchsia is intended not really for phones and tablets and whatnot, where if you touch a screen and it takes a quarter more second to respond, people usually don't notice that as much. Okay, it's not intended for mobile apps. They just use mobile apps as another test platform to try it out. Okay, upon inspection, media outlets noted that the code post on GitHub suggested Fuchsia's capability to run on universal devices, from embedded systems to smartphones, tablets, and personal computers. Now, anything that runs a microkernel requires very little resources. So that means they can run on smartphones and tablets, but they can also run on embedded computers in cars, in airplanes, in just about any system they can put into a embedded application. Do you guys know what is an embedded application, or do you want me to kind of give you an explanation? A mobile, okay. That's not embedded. This is not really embedded because it has its own interface. Okay. Now it is pretending to be something else. In other words, on my wrist is a computer that is pretending to be a watch, but it is not quote unquote as embedded as some of the other applications because it still has its own interface. Okay, it's just that the main purpose is not to do custom computation, but to report time, do all the exercise tracking and whatnot. A true embedded system would be one that is inside your dishwasher. That's an embedded system. It has very minimal user interface. It gets the job done. It is a computer. It has a computer system. Some dishwashers can hook up to Wi-Fi. That's actually one of the security problems that people have. Is they can infiltrate the dishwasher first, but because your dishwasher is inside your Wi-Fi network, now your dishwasher can be a launch pad to launch attacks against all of the other things within your Wi-Fi network. So you just look up, a dishwasher Wi-Fi, hack or vulnerability. Somebody made a dishwasher that had, like really crappy code, and people found a way to get into the dishwasher first, and then from inside the dishwasher they can launch attack to other computers in the LAN, in the local area network. Okay. So that's basically what an embedded system is it has minimal user interfaces. Anti-lock brakes is a very good example too. Because what is the user interface to an anti-lock brake system? As far as the end user is concerned, the brake pedal. That's it. It's just the brake pedal. Maybe a little indicator light on the dashboard too. But we don't really have dashboards anymore, remember. It's all connected to a single panel that is completely programmable. So the only user input is the brake pedal. You just kind of slam on the brakes, and at different pressure level or different levels, and then the computer will have to look at the rotation of the wheels, look at traction, look at all the different factors to help distribute the braking power evenly to all the different wheels. And that's a real-time application because as soon as do you guys know how ABS work? Sort of, kind of, not really? Okay. So anti-lock brakes is not really not locking. It is just very fast to respond to locking. Okay, so your wheel would actually, okay, so what happens is, when your wheel is not locking and as you apply braking, it will keep rotating in a smooth way. When it locks, your wheels just stops rotation, but it will be very abrupt. So your computer, the anti-lock computer, the ABS control system, is able to monitor the rotation of the wheel at a very high sampling rate. So as soon as it has any sign of locking, it will modulate the pressure on the calipers and start to release it, but not entirely, just a little bit until it starts to rotate smoothly again. So it would look for signs of we are starting to lock and then start to modulate that pressure. So in the old days, you can actually feel anti-lock brakes. Okay, yeah, it will just modulate, right? It will because it's hydraulic. But with electric cars, it's not hydraulic anymore. It is all electric. And the best part of electric stuff is you can actually adjust the actual amount of force applied to the brake pads. Okay, so I would guess I'm not rich enough to have a Tesla, not yet.
Yeah.
Okay, But I would guess on the Tesla, when anti-lock brakes engages, you won't feel a thing. You won't, other than the indicator on the dashboard saying that ABS is engaged, you won't know that you have just engaged ABS.
They feel like mechanical brakes. I mean, the whole slowing down process is
Mhm.
through the electrical motors, but the brakes are just discs. But I don't know what drives the discs.
Yeah, but the ABS experience is
Right.
not going to be the same. I think it's because feeling that click thing is crude. It's because of a crude implementation of ABS.
Yeah, we've never I don't think I've ever slammed on brakes.
But that's how it still is, right?
With Teslas, I don't
no,
think
but like on normal cars.
most cars, yes.
Because the morning of the first day of class in here, I had to slam my brakes on and I got rear-ended on the
Mhm.
way here. And it was like that. Just
Yep.
And I barely stopped, and then the car behind me
Couldn't stop fast
slammed
enough.
me. Yeah,
The best thing about it though is turning.
I did.
Slamming on the brakes and turning.
Mhm.
Not locking up.
Yeah.
That's really nice.
Well, ABS is not really just on one single wheel because they actually they monitor all four wheels to make sure that they apply the same force on all four wheels, because if you can just kind of imagine that half of your car, two wheels is on asphalt and two wheels are on gravel. Cars can do that. Okay, modern cars ABS.
Jeeps can do that.
Huh?
Jeeps can do that.
Well, because
one wheel's in the air and the other.
because it's mechanically locked.
Well, no, it's designed to crawl. So you go
Yeah.
from rock to rock, and you got to take the pressure off the loose wheel and put it on gripping wheel.
Because when you engage the all-wheel drive or the four-wheel drive thing, those you don't have a differential anymore. So if you try to drive a Jeep with in that mode and you try to make a turn, it will squeak like there's no tomorrow, because all four wheels are forced to rotate at exactly the same speed, even when you're turning. And when you're turning, the inner wheels are supposed to rotate
Well,
a
now
little bit
it's all
slower.
electronic again.
I don't think Jeeps are electronic.
It's
They are?
electronic, yeah. I turn a knob, go snow mode, rock mode. mud
Really? Is it a Wrangler or is it one of the other
mode. I have a
Jeeps?
Trailhawk.
Oh, okay.
Yeah. So.
Yeah, I think the Wranglers are still mechanical.
Yeah, my Wrangler is a little bit still mechanical.
Yep, cannot be fooled.
No, not this one. And it's not the Rubicon with the locking front hub.
Okay.
Yeah, Jeeps moved along that road. That's why they're all on the road. There's so many Jeeps out there.
But only if Chrysler improved the engine reliability. And also, stopped at those hacks, right?
Yeah, and they stopped them from rolling backwards and crushing you on the fence. Who was that?
That was Scotty.
Yeah.
Yeah, Scotty.
Yeltsin.
Yeah, you should know Star Trek.
What's his name? Yeltsin.
The Russian.
Yeah?
And yeah, his car rolled back and crushed him.
Ooh.
Yeah, it was at the mailbox or something, and just.
Yeah, he died really slowly. I heard.
Ooh, that is not a good way to go.
No.
No.
Now, given Jeeps being hacked and Jeeps rolling backwards. gotta
Yeah.
wonder.
If you want to watch, cars and how computers are now used to control cars, because it is embedded application. I saw this one about the new CRV
Check.
all-wheel drive. There's a video of how somebody was intentionally driving a CRV up a slope where two wheels diagonally opposing wheels will be off the ground or lose traction, and they're trying to see whether the computer knows how to divert torque to the two that are still with traction. And it did an okay job. It's not like a Jeep, but it did an okay job. It got out of that situation.
Yeah, rock crawling is intense.
Well, that's why people keep stealing those Toyota. What is the code of those engines? The old Toyota four-cylinder engines. Those trucks get stolen a lot because they got put into rock crawlers. You don't need a V8 in a rock crawler. You don't want a V8 in a rock crawler. You want a smaller engine and just gear it all the way down so that even you floor the gas, it's not going fast. Because otherwise you'd just be flipping backwards. So QNX is interesting. This is related to what we were just talking about.
Magenta looks really interesting, actually. Magenta looks really interesting, which is the microkernel underneath Fusion.
Right. So I think we had that open somewhere.
I mean, and the activity it's very hot. I mean, I'm just looking at it on GitHub.
Oh,
They're
okay.
all posts right now, so I'm thinking about downloading it.
Yeah, I was on this page because a student asked me what to study in college. What specialization would be interesting. I got way too many tabs. Here's a Tesla. I wonder what Tesla uses as its operating system. That's going to be an interesting question too, because it has to have some kind of operating system. The entire, if you look at a Tesla vehicle, it is a mobile app in its, truest sense. It's just automobile.
Special variant of Ubuntu.
Yeah, but okay, so it's not an RTOS. So I can see, how. Okay, I keep going.
Oh, but the motor control unit doesn't use one of the commercials.
Okay. Okay, I lost my tab. Okay, we got QNX. Okay, that's just QNX itself. Oh, okay, this is where we left off. Okay. I need to watch my own video, just backtrack a little bit so that I can keep my own stack of, okay, where did I left off before digressing into something else. So anyway, a microkernel-based operating system is a very good thing. And if you look at the licensing of this operating system, if you look at Fuchsia, it has a BSD3, clause, MIT, and Apache 2.0 license. It's kind of a mixture of those, they're all open source compatible licensing. So, which is kind of interesting because, it looks to me that Google is really trying to push this to become, the next operating system, for embedded systems. And, it might take over Linux in the long run. In the short run, no, because Linux has a huge user base, has huge support. But one thing that we have probably learned in the past 5-10 years is if a platform is really good, it doesn't take that long anymore to take over an existing platform.
And the thing is, it's a lot of accidental complexity is still left behind.
Exactly.
So I mean, if you think about our stereos, what
Mhm.
we used to build, and then what we're building today, we've thrown out all of that complexity.
Yep.
And so the operating system of yesterday and the new one of tomorrow,
Mm-hmm.
I think it's going to be a great opportunity.
It's a clean start.
Yeah.
It's a clean start so that they can learn from everything from before and then go we're not going to repeat those things anymore.
We didn't need
We're building it for the future. Yep, we're looking 5-10
really
years.
lightweight.
Well, if it's a microkernel, that's the whole purpose. So it's really exciting, to see that there's a new operating system being developed. It's just when is it going to be rolled out, and where can it find its way into? What can it find its way into? Those remain to be questions to be answered. Who knows? Maybe Fitbit will use Fuchsia as its own operating system, because otherwise, okay. So this is another sidetrack. Why companies use Linux? Okay, that's a very common question. Not to dump Windows, but more like dumping the other types of Unix operating systems. IBM switched to Linux like 10 years ago. HP switched to Linux about the same time. So both of these companies used to run their own version of Unix, AIX in the case of IBM, and HPUX in the case of HP. So all of their mainframes use one version or one variant of Unix or another. And both of those companies decided about 10 years ago, 2006 if I remember correctly, to switch to Linux. Why? What do you think?
They didn't want to deal with updating things themselves. They wanted the community to do it.
Yep. Now, in that particular sense, IBM also contributed to the Linux project. So they contributed the implementation of some of the really modern file systems, into the Linux kernel. So it's kind of symbiotic, In other words, IBM is not just exploiting, graduate students, putting their sweat into, enhancing Linux, but IBM is also in return putting their own effort into the Linux project and sharing their code with everybody else. But the whole point is, when something is open source, you get to leverage a huge community of developers, so you can test, you can enhance, you can refine the code using a global resource instead of just within a company. And that's one thing that Microsoft has not learned. Because Windows to this date is closed sourced, it's proprietary. Nobody has source code. I have not seen it, good thing. I have not seen it. Somebody actually leaked the source code of Windows a few years ago. Somewhere on the web, somebody leaked the source code. I didn't even take a look. I was not interested.
They needed to reinvent, but what are they going to go to?
Okay,
so Solaris ditched a long time ago.
Well, Solaris is Unix-based. Even though Sun put their own GUI on top, it is still Linux-based, and I think it is still X-Window-based as well, as far as the GUI is concerned. So maybe this is a good time to kind of switch to the notes that I type. So let's go ahead and go to. I put it into advanced topics because it's not really Android specific topics, because it basically, if anything, it is anti-Android. Okay, if you look up this particular link, it is in a way anti-Android. So it's a lot of text. I don't want to kind of bore you with all the text here. But I would start here. So when you look at Linux and even Unix operating systems, the first GUI, they make use of X-Window as the lowest level GUI support structure. Now X-Window by itself is a GUI system, but it doesn't have a lot of things that you need, like resizing windows, moving a window. So it is the XFCE4 or GNOME or KDE that is sitting one level on top of X-Window that is giving you the window manager and all the really good stuff that gives you the actual usable user interface. But X-Window as an underlying platform is very interesting because it's a client-server based platform. In other words, it was designed so that your app, okay, let's say you're running a particle simulation app that has a user interface. Particle simulation takes a lot of juice to run. Okay, so typically you want to run it on a really heavy-duty server, not on your PC. So that is your client program. Your actual computer that you have physical access to is called the client. It's called a server program. So the client-server model seems to be reversed, but it's not, because the request is still being sent by the client. So the particle simulation program is the one that is sending a request to the computer that you're looking at and go like, hey, I want you to display this stuff on the screen. So the PC or the computer that you're looking at is responding to requests coming from the mainframe computer that is running the quote-unquote client program. So the client program is the heavy-duty program that is running that might take like 200 gigs of RAM, and 18 processors at the same time. But it's sending the display information to a relatively inexpensive and dumb quote-unquote terminal. And X-Window was designed to do that. This is back in the days when people used mainframes. This is way before PCs took over. And then in order to lower the expenses, instead of having everybody to have an expensive Sun workstation, people said, hey, I'll just give you a dumb thin client. It's called a thin client back in those days. That will run X-Window kind of at a minimal level, and then all the heavy-duty computing will be in the back room in some kind of huge server farm. And then after that time, PC came along, and people say, okay, I don't need the backroom mainframe anymore. I got my own PC, standalone, isolated from everything else to run my app. And then guess where we're going now? Back to the mainframe. Except we don't call it the mainframe anymore, and it's not in the back room, it is in the cloud. But the amount of processing power and the amount of storage and the cost of everything, the cost has gone down tremendously. The amount of resources has increased tremendously. But we're getting back to that model. Okay, the heavy duty stuff is actually being done not on the device that you're holding onto, that you have physical access to. What you have physical access to is now a terminal. We're going back to the terminal concept. It just doesn't look like a VT52 or one VT100 terminal anymore, but the idea is still the same. So I think that really has a lot to do with the future of Android. Okay, because if you look at Android, okay, if you scroll down a little bit, Android itself is a rather thick stack on top of Linux. So we'll take a look at, why I say it's a rather thick stack. We have seen this picture before, so it's not the first time we have seen it. Porting Android, so I'm just borrowing the picture from an article. So when you look at this picture, that shows you the stack. The red part is the Linux kernel, which is basically the stuff that deals with the file system. Well, technically the file system is not really a part of the kernel. It is done by modules as well. But we'll just count it in all the device drivers and whatnot. We'll count all of those as part of the Linux kernel, even though technically speaking they're not a part of the kernel. Your apps are running here, the top part of the blue. That's where your app is going. So you are 2 layers from the red. The virtual machine is right here. The Android runtime, the virtual machine is right here. So on top of the virtual machine, you have the framework. On top of the framework, you have your apps. So you can just imagine the kind of efficiency or their lack of with this kind of thick stack. So when your app is doing something in Java, okay, like any type of computation to respond to a click, to calculate, the vector of, where you're swiping, the direction of swiping and stuff like that, you are going through all of these stacks before you get to the event. Okay, your actual touch event is getting into here. Okay, because it's the touch screen chip driver that is the first one that gets, oh, somebody's touching me. And it has to get its way all the way up there, and then when you update something, it has to get all the way back down here to display it. You can see how this is not exactly efficient. Now, but it has 2 main advantages, okay? Because people would then ask and go like, but why do you think Google chose to do things this way? And this was chosen a long time ago.
Portability.
It's portability and also time to market. When you use Linux as the underlying operating system, it's already there, done. You don't have to do much. Maybe a little bit in terms of driver code, so you have to have Qualcomm to write some of the driver code for Linux, which Qualcomm is not very good at. But other than that, Linux is already here. You have files, you have processes, you have threads, you have everything that you need to run any type of program, general purpose programs. Java is already done. You have a huge community of people who know how to write Java programs already. You also have a huge Java library or class hierarchy already in existence. Now, maybe most of the GUI stuff in regular Java won't work in Android, but all of the other stuff, the threads, the interlocking or the synchronous part of the Java programming language, lists, all of those things, they're in place already. You don't have to reinvent anything if you use Java. So by choosing the red part as well as the yellow part, Android only has to do with the blue part for the most part. It uses SQLite. And guess what? SQLite is already in existence prior to Android.
Coded in Java.
Coding, well, is it coded in Java? I think it just has a
Probably not.
interface in Java. But it's Java accessible, definitely. So that's why I think Google chose to use this particular stack, even though it is inefficient. The time to market part is why it is advantageous, because you have to remember Android has a late start in the game. iOS was already chugging along when Google decided we want something too, and they caught up and passed exactly. So I think this is historically why we are currently dealing with a thick stack, And from this class, you also learned that Android programming is not really exactly a breeze. There's a lot of stuff to look up. There's a lot of stuff where it doesn't work, but we have no idea why it's not working. Okay, there's a lot of
blow up anywhere in that stack.
exactly. You have a lot of layers where if one layer doesn't work, it doesn't work. But it doesn't always give you good feedback of where it is not working. It just gives you a runtime error of some kind of exception. Sometimes the exception is good, it tells you exactly what is going on. Other times it does not. It just fails silently. So this is why I think things are going to change. So when you combine this picture and look at how inefficient it is, and then combining that with the not disclosure, but the discovery of Fuchsia and Magenta, I think Google is actually going to replace Android in the long run with Fuchsia. But they're not going to announce anything, even to that effect, because they don't want to upset the developer community. They don't want people to panic and stop learning how to use Android, because
You're gonna tell them they're gonna have to go back to C++.
That's the other thing.
That's the only way you're gonna get real time out of it. You can't use that virtual machine with garbage collection.
Or you have to have a new programming language that combines the efficiency and also the bare metal nature of C and C++, but with some of the nice things of Java, like not having to manage your own heap or.
Wouldn't it be wild if they picked up Swift? Then we'd have the same language on both platforms.
That would be cool, but I don't see it happening. As a developer, I think it would be great if we have one single programming language and one single framework. But I think Google, is not
Swift
going
looks like
to
a
use
really
Swift.
smart language. I mean, what they put in for optimizations and how it's all set up to just unroll itself, it'd be a hard one not to consider.
Mm-hmm. Yeah, but Google is not. I think Google, the relationship between Google and Apple may not make that happen very easily. Now the developers may push Google to go in a certain direction, but I don't know how much.
It'd just be funny if they went over and ate Apple's lunch.
Well, they're already doing that. They're already doing it. So the advantage of Android is it is using Linux, it's using Java, two existing platforms with a lot of people being familiar with both of those systems. So they hit the ground running basically, without having to spend a lot of time to reinvent stuff. But at the same time, okay, so I wrote somewhere here. Oh, there you go. I ran out of time to write the entire thing because Android grew to the current point. In other words, when you look at the first Android interface, it's clunky, it's slow, things do not look very good. They don't have many of the features that we do have now. So it grew to the current point, but growing a GUI means that you need to maintain backward compatibility. And that's why I have the second sentence here. Android as a platform, as a framework, is complex because it has a hefty backward compatibility baggage, which is the same baggage that your x86 processor has, is backward compatibility. If Microsoft tells Intel to go like, okay, we don't need binary backward compatibility anymore. Go do your thing, make the processor energy efficient, make it really fast. Intel is ready for that challenge, but Microsoft is not. Microsoft is not ready to give up binary backward compatibility. That's why your PC is still taking up, even with the new process, even with an 18 nanometer process, your i7 processor is still taking up more than 100 watts of power. That's a lot. If you look at
That's a light bulb. That's a light bulb.
a pretty big one too, because most LED light bulbs these days, 20 watts will give you lots of light already. Okay. If you get a 35 watt, LED light bulb, people will think that you're growing marijuana. Because why would you need so much light? Those are in industrial, for industrial stuff like in an auto shop, they would use 40 watt.
So the regular old incandescent was a 120 watt bulb.
Only putting out like this much light.
Much light and a whole bunch of heat.
Yep. Yep. You cannot use a bulb to heat up anything anymore.
Yeah, they used to have an easy bake oven. Just put a 120 watt bulb in.
Yep. And they also have those 500 watt halogen lamps.
So, well, yeah, those
Yeah, you don't
those
touch
start
those.
Fire.
Yeah, I actually saw a moth, go up in smoke, not flame, not quite flame, but smoke, when it landed on a 500 watt halogen lamp. It was spectacular, and then it smelled really bad. But I'm not kidding. 500 watts, with a little tube like this, to dissipate the heat, it's hot.
500 watts. I mean, the Tesla has 85 kilowatts, so
That's a good chunk of it.
Yeah.
Yep. So all of these things is pointing to one direction. Okay, Android is slowly going away. Google may not say anything about it, but they will be forced to say something about Fuchsia in the summer because there's an event called Google I/O conference. Okay, and it's going to be soon, May 17th to 19th, next week. Yeah, today is the 10th, so it's next week. So this may be the time when Google will finally say something about Fuchsia and also Magenta. So if you have time, and I'm not sure whether you have to pay to go there or not, but if you have time and you're interested in this type of thing, I would highly suggest to go. I cannot because I have another event to go. I have to go to the Maker Faire. Yes, I did say I have to because I'm going in the capacity of a professor for a grant application. Otherwise, I'll be going to the Google I/O. Yeah, it looks like it's going to be really cool because it's going to be at the Outdoor Shoreline Amphitheater. That is cool. If you look at attending, let's see how much you have to pay to do that. Event, Google.
It could go Swift. There's articles on there about
Swift?
Google adopting Swift.
Cool.
So they have this issues with Java and Oracle.
And Swift is already open source,
It's already
so
open
Apple's
source.
not going to say.
Then it becomes a matter of libraries and whatever you want to map it, but the very core of the language, I mean, they're fundamentally easy. I mean, the core of C was 39 operators or something?
It's good to have some competition anyway.
True, competition, but only in the sense that it will promote, advancing of technology and getting to the next step. But standardization is also good because then developers do not have to learn a gazillion programming languages.
We don't have to learn the language. We just have to learn the libraries and the
framework.
platform and the framework and the window manager, but the language.
Yeah. But Fuchsia is going to, I would imagine Fuchsia will have a cleaner framework. In other words, the learning of the new Fuchsia framework is not going to be as tedious and clunky and has all the baggage of backward compatibility as Android as we experience in this class. It'll be nice. And also, I think Fuchsia would probably also have future or forward thinking hooks for virtual reality, for augmented reality, for things to come. Dashboards in the car and
That's
stuff
where
like
the
that.
clunkiness is going to be. It's the things we don't know how to build them yet. But everything else, like all the audio, pictures, all that, all the stuff in fonts, we've narrowed it down from 1,000 switches to.
Well, if you look up Android operating system in the Wikipedia page, you will see that Android was not intended as a phone OS. That was not its original intent. I mean, the name Android, why would you name an operating system on the phone Android? That was not what it was intended for. So when you look up the history of this thing, okay, so you have to look up, here we go. initially developed by Android Incorporated, and Google bought it in 2005. Android was unveiled in 2007 after Google bought it. But the original intent of Android was embedded systems.
Oh, the same thing.
Yeah, yeah, it was intended for embedded systems. Let me see if I can find that. Okay, maybe not here. But if you look at the original intent of Android, it was not designed for mobile applications. So they kind of coerced the whole thing, the framework, to work with touch screens and tablets and stuff like that. And now they're trying to expand to cars, to virtual reality and stuff like that.
That's
so
why they need the real time.
Mm-hmm.
If they want to hook into anything, they better complete.
And you also need a much more efficient stack if you don't want those things to have a generator attached to it.
It gets really good with virtual reality. That could get a lot of people to use virtual reality. Because right now it's like you have to buy everything, you have to set everything up, like a ton of stuff. But then they could just add some sensors on the phone that'll track your head movement, so you won't have to buy as much equipment just to use it.
The sensor technology is not quite there yet. Even though the technology does exist, it is probably quote unquote still too expensive to incorporate into a consumer application.
I'm talking like 5-10 years.
Yeah, but in the future you will see eye movement tracking and many other things that I kind of mentioned. Because you have to put on the headset, so it's easy to have the headset to also have pick up your brain activity, whatever that's easy to pick up. Okay, I don't know exactly how much can be picked up without using a lot of expensive hardware, but I would imagine there will be some stuff that is easy to pick up.
Well, a lot of our good technology came out of things like the space program and application reuse. We just need another something
Mars.
to move us forward. Mars moving
Mars.
us forward, and then we'll solve all these problems, and then they'll show up in our devices.
Yep, that's why people who are born now they call the Mars generation.
And they're going to Mars. Somebody in that pile is going to Mars.
I don't know whether I want to go to Mars or not.
I'll just put you in the closet for 4 years. How's that?
But you're right. A lot of the technologies that we got, either are from the military, or it is from space programs, or a combination of thereof.
Something driving some problem that we really have to solve, and then we get all these spin-off technologies.
Right. Yeah. NASA owns a lot of technologies. It's surprising how much stuff they own.
Not the EPA. That's an acronym for sale now.
Yeah, EPA.
Decommissioned every day.
Yep, exactly.
Scary.
Yeah, they took out everything that relates to global warming, and now I didn't read this myself, okay, but according to what my wife said, the president said, global warming, melting ice, that's good. It opens up new trade routes.
But you really said that?
I don't know. We can look it up from
Global warming. It's
ice
awesome.
trade
Good.
route. There we go. As global warming melts sea ice across the Arctic, shipping routes one thought impossible are now open. And I think the president quoted that and say that global warming is a good thing. What are you going to trade? You cannot grow much stuff anymore.
I mean, when you're already as old as him, he's only looking for.
But he has grandkids, right? His own youngest kid is pretty young.
Who cares about kids?
That's the one thing that Jimmy Carter, when Jimmy Carter had to bring the Egyptian president and the Israeli president together because they were doing this, back in those days, back in Carter's administration. The one thing, he was trying to go between those two and they would not talk to each other, they would not agree on anything. The one thing that broke the ice was the mention of grandkids. Okay, when Jimmy Carter, told those, leaders and go like, don't think of yourself. Do not think of your own children. Think of your grandkids. What kind of future do you want your grandkids to live in? That opened up the conversation. Both sides decided, oh, if you talk about it that way,
This has
I'm
to
okay.
end.
I'm okay to talk now. Yeah.
This has to end.
Yep. So, getting back to Android. So when you look up, a lot of these things, Java itself and also Android, they neither was intended for mobile computing or general purpose programming and stuff like that. Both of those were actually intended or targeting embedded systems, and both failed miserably, on the original target. But they were in the end they fueled something else that was actually quite useful, which is kind of interesting. Unintended stuff happening. So I would definitely encourage everyone to at least keep an eye on the Google I/O event. It's an annual thing that Google does every year, and I think in this particular one they will start to talk about Fuchsia, Magenta. And you said Swift is on the schedule already, so that's cool. We are looking at some important changes.
I think if they saw that Apple was going to be able to do a highly efficient programming language mapped to hardware, and it was open source. So. I might not try to invent my own just to start over again.
Oh, Google is open to using stuff from somebody else. I mean, they don't have they are not they're not like Microsoft where they have to customize things to become their own. Because when you look at C#, it is not C++. It looks like C++, but it's not. You look at is it J something? They hacked Java, right? In the good old days. They had their own version of Java.
Something like that, yeah, I forgot.
They poisoned the standard. So I would definitely look into that because that's going to be useful. But the bottom line of today's lecture or today's discussion, it's more like a discussion, which I prefer, is what you learn in Java may not actually be that important in 5 years. Okay, because in 5 years, I think Fuchsia will start to roll out, as a replacement operating system. The most difficult part is going to be apps. Okay, with all these, how many apps do we have in Android? It's huge. $2.2 million available apps.
No,
That's Apple. Android users were able to choose between 2.8 million apps. Apple users have a selection of 2.2 million apps.
It's surprising that there's almost as many, considering the difference in Android versus Apple and the number of devices.
Well, Apple was ahead of the game, so
Yeah.
everybody's. I mean, I built apps for iOS.
I remember most of the games during my high school years were mainly just made for Apple.
Mm-hmm.
And then
It was
they got
just
ported
ahead.
over to Android later.
Well, because they were there first. They started off with the iPod. Okay, so the iPod was the starting point of iOS. It wasn't iPhone. Now the iPod, they had the iPod Mini, which had a kind of like a minimalist, user interface. There's no display of any kind. You just kind of touch and it starts to play. But they also have the mini iPod with a display, and I think that was the original
I
iOS.
think it was second.
Was?
Yeah, the iPhone came out in 2005?
So iPod line. No, it's not 2014.
First version, 2001.
2001. Okay. And it's eight.
Yeah, that's the old ones with the dials on, yeah.
Yeah, but the one with the display, they may not be running the current iOS though. Before the release of iOS 5, the iPod branding was used for media player, included with an iPhone and iPad. So you're right. Okay, so iPhone was the first one to use iOS, and then they backported it to the iPods. But iOS is interesting too because since we were looking at a thick stack, iOS is probably not much cleaner. So if you look up the iOS stack, okay, iOS stack, and look up images. Just at a glance, not much better. Okay. It's not that much better, except they instead of using Linux as at the bottom, they use BSD, Linux BSD as the bottom layer, and then they have all kinds of stuff. Its own framework, Objective-C private framework, and then you have the Objective-C user interface framework, and then you get to your actual apps. So it is still a pretty thick stack. And once again, the disadvantage of this particular stack is Objective-C was not a popular programming language. It's not like Java, where you can just pull somebody out of a class and go like, oh, can you write a Java program? Yes, I can. With Objective-C, not so.
It's got C, C++, Objective-C, and Objective-C++, all wrapped up in it.
With all the baggages.
You can do a function, arrow, star, do a method, then get the selector, put in the square brackets, and have no idea where you jump to.
That sounds like Perl to me. Except Perl was actually invented or designed by a single person.
Very well.
Yep.
That was programmable extraction and report language.
Yeah. Yeah. It was a pragmatic programming language by combining, awk, sed, and all bash and all kinds of scripting language at the time. So it wasn't designed to be clean. That was not one of the design objectives.
No, it was inheriting the syntax of all the
Exactly. It was intentional. Those are not baggages, those are features. Yep. So I think it's going to be interesting. I think we're at a point where the current framework is so difficult to deal with because it's getting too big and has too many backward compatibility issues and components that it is forcing forcing Google to start from scratch and go like, okay.
Well, if you think, we were talking about Sphere 5 the other day. That whole graphics library 2 layers up with all the drivers is
That's going away.
It's going straight to chip.
Yep.
So
But then
once we start ripping out that kind of technology and we finally decide all the chips are going to adhere to the same protocol, we take out the driver land.
But that requires a kind of redesign of the entire stack. You cannot use Linux in this whole stack anymore.
Yeah, it's not a service.
Yeah, because Linux as a kernel does not even do anything that's graphics. So it is up to the modules, the device drivers, to directly kind of talk to the hardware. So you have your device or video driver, or this is the software driver code, and that directly interface with the chips. Okay, so this one directly talk to the chip, but your app is all the way up here, going through the JVM and all the other stuff. To talk all the way back down here is expensive. Going through all these layers, and then everything has to go back up.
And now that we have the GPUs, I think they'll make that more of a straight line.
The GPU has direct draw. When you look at the regular Linux kernel, they uses the direct draw driver, which bypasses some of the X window drivers to talk directly to the hardware. And that's why you cannot use anything that uses direct draw. Probably is not X window compatible 100%. You cannot do it remotely because it takes a much higher bandwidth to talk directly to hardware that is not easy to do through TCP/IP. So forget about watching a video using VLC remotely, using the client-server model. So that's going to change because with Linux being like this, and then you have this entire Android stack in between here, there's nothing can be done efficiently. It's just not possible. So when they redesign the kernel, the microkernel, they probably will have to design it so that there's a very quick and easy way for your app to directly interact with the hardware. And that takes a different way of thinking because this kind of thing.
Now we have to manage concurrency.
Yep.
And that's really what their thing will be able to do.
You have to manage concurrency and also the awareness of what features are available. What is the resolution, which part of the screen is this chipset actually directly managing, that has to be coming from your app directly, not going through the entire stack. So that's interesting because OpenGL is in a way kind of like that. It does allow you to have some degree of direct control over the GPUs.
Yeah, the Spear 5 is the one I see is replacing the OpenGL.
Okay.
SPIR 5.
Mm-hmm.
V, I guess. That's the one that we were talking about for you, for the new graphics that they're putting, and it's already in Android.
Okay.
So.
But remember, Android itself is on its way out.
Well, I think they're bringing in the new methods, and they're on the way of deprecating the old tools. And it's just that they had so many things. Like, I mean, you've seen it, right? The difference between a text edit, and edit view, and a button. I mean, they're all just things with light layers of veneer wrapped around them.
Yep.
And we have to put them into our libraries, and then remember which one we want to use.
Yep. And then when you have this class extending this class, extending this class, extending this class, it is not efficient, especially in Java. Because remember, Java has not virtual function. What is the concept? More polymorphism built into it, and polymorphism has a lot of indirect thing like looking up, looking up, looking up, looking up. Every time you inherit, there's another layer of looking up. So when you have sub class of something, that is in the framework, everything that you do is going to be a little bit slow. It's going to be inefficient. So that's going to be. I'm excited to see how this is all going to play out. Now this is going to be a huge management issue within Google, because you have to continue to develop Android. You cannot just say, oh, we're going to stop Android because we got this new thing coming along. But you have to divert your resources in the right way, so that Android will keep going, and hopefully, things that you put into Android now, or some of the effort that you put into Android now, will find an easy way to merge into Fuchsia in the future.
You can see the APIs moving. Pull up this one alongside.
But
you start bending the APIs.
Right,
you
but
introduce it, and you continue.
But you have to ditch the backward compatibility, baggage, the stuff that you don't want to merge into the Fuchsia branch.
You want to create a new platform.
Yep.
But you want to keep the store, the app store.
That's going to be a big challenge. That's going to be a huge. Well, okay, I take it back. Okay, I take that back, because with Fuchsia, what they can do is to have a compatibility layer, so that old apps can still run in the new platform. It just doesn't look as cool or as efficient as native apps.
Yeah, especially if we use the app compat activity, I guess, or something.
Ooh.
And then they really tweak it to go to Fuchsia on us,
and then they tweak Android Studio to have a button to port your project directly into Fuchsia.
Yeah, they can do it. They can pull it upside.
They can probably do something with.
Microsoft changed operating systems. They went from DOS to Windows, and then they never moved again.
Well, technically within Windows, anything that is NT-based is different. Internally, it's really different.
Windows
ME.
Windows 3, Windows 95, Windows ME, Windows.
Yeah, Windows all the way to ME is the old version, where it's the thin layer, it's a GUI layer on top of DOS, but there's no real operating system behind Windows. And then once they moved onto Windows NT kernel-based operating systems, commercially, they use the first one that was really popular was Windows Windows NT 3.51. That was the first really one that got spread out.
Had the good web server on it.
Yep, that was actually usable. And then they merged the NT kernel back into the consumer line with XP. That was the first one using the NT kernel. And then after that, everything is just NT based. The NT kernel is actually a microkernel. It's actually really nice. Of all the Microsoft products, software products, the NT kernel is really actually a good piece of engineering work, except it's not visible to the end user. Windows being unreliable has nothing to do with the microkernel itself. It's all the other stuff that you wrap around the microkernel that makes Windows unreliable. It's the same thing with Android too. The Linux kernel, even though it's not very nice in terms of design, it's not a microkernel, it is actually pretty stable. all the crashes that you see, all the, there was one bug where certain types of Android devices, when you try to hook it up to a Apple router, it would just fail. It would just, it would connect for a very brief amount of time. It would just and then the kernel would crash. And this, as it turns out, it was a bug in the Qualcomm driver for the Wi-Fi chipset. It's not part of the Linux kernel. It's not. The Linux team who wrote it is Qualcomm, and it's not even open sourced. Qualcomm did not open source their code, the driver code. So you don't have a whole community of people going through that code and go like, oh, this doesn't make sense. Let's fix it. So this is all quite exciting, I think. Any feedback, comments? How many people intend to write more apps, in the future instead of just, oh, I just took this class, I'm getting a certificate. Okay. So you might want to.
Why not? We put a lot of effort into this.
I think in the future you will see a merge of everything is going to move to a microkernel type of thing, and embedded systems or real-time operating systems will once again be something that people want to look at, because for the longest time that's kind of like a really obscure niche in the embedded system market. But now that we have everything has an operating system, my watch has an operating system. It becomes more of an issue, like, how do we make a lightweight, energy-saving microkernel that can also do all kinds of stuff? Putting that kernel onto a PC, onto a desktop, easy peasy, because it has so much resources. It doesn't need a microkernel, but a microkernel would run easily on a desktop computer too. So this is something, if Microsoft is not shaking, they should be. Because once Magenta and Fuchsia has matured, it can easily move into the desktop market. Especially when people start to write apps in a way that will also work on the desktop.
So that's a huge platform that's ready for someone to take it over.
With
all the PCs.
all the PCs, I don't know about that because
if
PCs.
You could integrate an app store along with the PCs and then drop something new onto old or even new hardware. I don't use Windows boxes anymore.
I have no doubt that this may be on the plan of Google, is eventually to, because the first attempt was Chrome OS.
Chrome OS.
Yep, Chrome OS was the first attempt.
Was it Google Notebook or what was the little Chromebooks?
Yeah, Chromebook, but it runs a Chrome OS, which is a lightweight layer on top of Linux.
Back when you started, like the Windows server, it was operating more like a Windows server.
Right.
Like server.
But it is still a general purpose operating system. It's just that they disable a lot of the features so that end users cannot get into trouble. You cannot they took out gpart. You cannot reformat the hard drive. The utilities they took out. They took out the CLI, so it's not easy to get to the command line interface. So but for the most part, it's just Linux. If you look at Chrome OS, I would not even be surprised if it's X window based. Chrome OS. I just want to look at the stacking of Chrome OS. Okay, hardware support, architecture, user interface, new window manager. Okay, there we go. But it doesn't explain down below, underneath, what it uses. So I'm not sure whether it's X window based or not. There we go. The window manager handles user interaction with multiple client windows, much like other X window managers. So when it says much like other, it implies that Chrome OS is X window based. Which makes sense because that's a good chunk of code right there.
Free.
Yep. Yeah, they just have to make it look different compared to GNOME, KDE, and also make it lightweight so it doesn't use up a lot of resources. But with Fuchsia, this can also change, in the future too. So I think Google actually has plans to take over laptops and also desktop computers. I just don't know whether
I think
Microsoft.
they have plans to take over the world.
Well, but just having the wish to do it doesn't mean you have the means or the necessary engineering, intellectual capacity to do it. But by looking at the positioning of Fuchsia and Magenta and how they are sliding it into the mobile market, kind of without any fanfare, they did not promote it. People found it just by
We don't
what
know
is
that
this?
it's mobile market yet. I mean, we don't know that it's designed for the phone market.
I don't think it's designed for the phone market
You know,
at all.
Like you say, it's probably the car market, the
Mhm.
IoT market.
Yep.
you know.
Yep. So they have a much more, much deeper plan. They are only using the mobile market to kind of as a test platform, which is great because you
Look at all those hands.
it can fail. Nothing. No one's gonna die, right? And you're not controlling a power plant or anti-lock brake system. So it's a great way to test it to kind of you go through that code and make sure that the kernel itself is stable. But I think there are plans to kind of put it into cars, put it onto tablets, replace Android, and so on. So Microsoft really should be starting to shake in their boots, but I don't think they are. I don't think they understand the implication of something like this.
They've been pretty. They survived longer than I thought they would.
Well, they hold on to their market share using a different
Licensing.
using licensing. Exactly, they are a licensing-based company, and they work very hard to work with government agencies, community college districts, and so on, because they have an army of what they call the value-added resellers, the VARs, VARs. So they have a huge army of VARs, and people are paid, and their only job is to talk to government, acquisition, procurement, people, and go like, okay, continue licensing with us. Oh, by the way, we are now offering a new product, and a new licensing, option.
For 3 easy payments.
Yeah, exactly.
But it could be like Oracle. I think Oracle sold more license to the government than the government had computers.
Oracle
So that's Larry Ellison.
well. Now I'm not sure about Microsoft, but Oracle sell licenses based on cores.
Yeah, they sold more licenses than the government had computers. This is, what, 10 years ago?
Well, that's their army of VARs, doing their job right. But as taxpayers, I'm not too happy about it. Alrighty, so I think this is great. I mean, just having the chance to look into the future, because when in this class, I'm pretty sure that we realized the limitations of the Android framework. It can do a lot if you spend the time. If you spend the time to look at the class hierarchies and read the documentation, read some of the source code, you can do just about anything. But it's not easy. It's not efficient.
I actually found an article from MIT EDU or something that's probably programming Android 5 years ago, 6 years
Mhm.
ago. Back they were still using Eclipse. And it made a lot more sense to me than just skipping all those steps. I found it anyway. So it's a little it's a little article. So I'm using that, and all the code still ports.
Mm-hmm.
But I have to do it more manually, and all that stuff makes more sense to me. Whenever the disappearing magic stuff happens, that's when I get confused. I don't understand how it really connected. It doesn't.
Well, that's
Not
when
enough data there.
That's when you put a breakpoint when it's just about to call a method of a superclass, and then you trace the code.
Oh yeah, I love doing that.
Yep. But you only have so much time. But
Hey,
you
I
only have
started
so much
over again
time.
this morning for the last time.
For the last time. Famous last words.
Well,
the
for
last
this,
time.
for this iteration, yeah, I took out the database. I decided last night I was going to redesign, throw the database away.
Okay.
Flat file it, run it with logs. So have you seen log processing taking off? That's one of the big data techniques.
Yeah, I've
All of
heard
it's
of it.
just append to the end of the log,
Mhm.
and then you can have as many cores as you want ripping apart the logs. So I'm going to build it with a log. So all the events happen, enter a log, and then that makes sense, and then you can clean the logs.
Linux itself uses that approach a bit, because if you look at /var/log of any Linux systems, they have tons of logs of every kind, and then most of the daemons, most of the server applications or most of the server processes have configurable log output. So you just log everything that is happening, what is coming in, what is going out, what is processing, and you can have another program to process the log, either at the same time, at a later time, look at the archive of the logs and do some post-processing. So that
The
approach
interesting thing is it's all sequential. All the events happen in this order.
And you can
So
reconstruct.
You can use many computers. They all see the same event stream.
Yep.
I mean, it's intense how simple it becomes.
And on
You
top
wanted
of
to distribute all those events to all these machines and keep them in order,
Mhm.
and you didn't have a log.
Well, the log files is kind of a thing of the past now, because a lot of logs are not on the same computer. So when you are dealing with a computer that is network connected or has almost a guaranteed network connection, a lot of times the logs are actually done remotely. So your computer is sending its log to some other place, a process running on another computer is actually logging for many other computers.
Yeah, I'm not actually referring to the log itself, but the serial nature of the log,
Right.
the ability for all these clients to read it. So I mean, I could log something like snap a picture,
Mm-hmm.
and then that's when the picture was snapped, and then I can look back in the order and see exactly when the picture was snapped.
Yep.
And that's my storage, that's my database. I
That's
just
the-
process the log, and I know exactly what happened all the other times I've run.
That's the advantage of having inexpensive storage. That was not true, back in the 80s or even the 90s. Hard drive space was expensive. You don't want to log everything. If you can throw away something, throw. that was the model back in those days. If you don't need it, don't save it. And these days it's exactly the opposite. Save everything. Don't delete anything. Save everything. Yep, because storage is inexpensive. This is one thing that was coming out of a conversation yesterday too. Another student, commented that he read an article some time ago how the human brain has more interconnections and is more complex than the internet. Well, then I asked him, when did you read this article? Because the internet expands on a very fast rate. The physiology of our brain does not change. That's the big thing, okay? Because of Moore's law, every 18 months, you basically quote unquote double everything, right? Because
Double the computing process. The disks change every 12 months. Networking goes.
yeah, technically speaking, you only Moore's law describes the shrinking of the transistor, but it loosely translates to doubling capacity of storage, doubling the processing power, and so on and so forth every 18 months. And that's really significant. People don't think about it that way, but it really is significant because it's exponential.
Yeah, look, it was made from the iPhone of 2005 to
Yep.
2017.
Yep.
That's 6 doublings.
And that's why we start to see, storage being inexpensive. It's dirt cheap because of the doubling effect every 18 months. So 18 months from now, it'll be even less expensive. Amazon actually has to decrease their pricing on their S3 cloud services multiple times because it's getting less expensive and they just want to be more competitive and they can afford to drop the price, and they have been dropping those prices consistently.
I did a cloud system for processing medical reports on patients. So it generated tons. I just generated all these reports. That's all I did. Storage, and then the clients had instant access to the data. So yeah, you just calculated everything.
Yep. The key is how do you index everything. That's
the name. Yeah.
Yep. That is the name of the game, is indexing into the log.
I just hashed the question. So I had an XML object which described all the complexities. I would run that through a hash,
Mhm.
and that's my key. And so I put the bit representation, the population, the map key. And then I could do all kinds of Boolean algebra across the various keys, and each one was a really complex question, like, females over 50 that have diabetes, that have, this, and then I have that as a signature, and then I had a bitmap of those
Mhm.
patients, and then I could do those females, and then integrate it with those that had cardio disease, and and then that would give me the new.
But how do you go through the records to filter?
Which records? The medical records?
Yeah.
That's when we use the real XML to process
Oh, okay.
the data. Once I found out the patient was one of these,
Mhm.
then I have them in a bit array.
Okay, so you have the indexing mechanism running as you put records into the
Yeah,
database.
and so what I did with
Yep.
that question is a unique question, so that became a unique signature.
But is that question asked to every single medical record? So what happens when you add new questions?
It becomes a new signature. It is
And
a new
do
question.
you run that question to all against all the
Every
existing
night,
records?
Every night.
Okay, so you re-index basically.
Oh, yeah, I had hundreds of nodes crunching away on thousands of reports, producing
Okay.
massive
Gotcha.
numbers of populations.
And
And
then
then the client could actually, they could then say, give me an intersection of different questions, and I could do that really quickly.
Because it's a big map.
It's a bitmap.
Yep,
And then I just index back to the patients.
that makes sense.
Yeah, it's a huge system.
But it's nice because it's not relational. So now you can actually
But the-
use parallel computers to do the processing.
Absolutely, absolutely.
Because you can't do that with a relational database, not easily.
No, not at all, not at all.
Just imagine you having to do all that stuff, using a relational database.
Well, the real thing is I had to rent the computer.
Mm-hmm.
So it didn't matter. I mean, if you look at my computers, they're burning 100% CPU. I mean, they're sitting there crunching all day long, and then I had those were the background processes, and then I take the same queue, and if somebody asked a question I'd never seen before, and the user is really there, right? Then all of a sudden, all my populations were divvied up into tiny chunks, and then all the computers would shift off of background mode into foreground mode, pick up those populations, and answer that question right now.
Mm-hmm.
And then back to crunching all the reports for the night, because I didn't have to have the data done until tomorrow.
Right.
That was a beast.
That sounds very interesting.
It was fun. It was fun.
All right, well,
All right.
very cool. So
See
next
you.
Monday is our presentation day. We only have 8 students left on roster, so each student has up to 15 minutes to do the presentation. I would make it at least a 5 minimum. But if you want to talk about what kind of obstacles you ran into, how you solve the problems, stuff like that, be my guest.
And when did you open a Dropbox for us, or how do you want our
for the project itself?
You can.
How about using a Google Drive link?
Okay, doke.
Yep.
You post up there what you want us to do.
Okay, I will post it. All right, cool.
I was wondering about that too.
All right, see you Monday.